It is about time to face the fact that there is something very, very wrong in the way.
The universe has always whispered its secrets to those who dare to listen. But what if the very fabric of time itself is hiding something so profound it could unravel everything we thought we knew? Imagine standing at the edge of a vast cosmic ocean, where the waves of reality ripple in ways that defy the ticking of a clock. This is no longer the stuff of dreams or philosophy. It's a possibility grounded in a discovery that's sending shockwaves through the world of physics. Google's AI, sifting through the chaos of particle collisions at the Large Hadron Collider, has stumbled upon something extraordinary. A pattern that doesn't just bend the rules of physics, but seems to exist outside the flow of time itself. It's as if the universe has revealed a hidden door, one that leads to a realm where past, present, and future blur into a single, eternal moment. This is the story of a discovery that could rewrite our understanding of reality. A tale that begins not with a bang, but with a whisper. A whisper that grows louder with every moment we dare to explore it. Deep beneath the rolling hills of Switzerland, where the Large Hadron Collider hums with the energy of 1,000 suns, scientists have been chasing the smallest pieces of existence. Protons collide at unimaginable speeds, shattering into fragments that reveal the building blocks of our universe. For years, humans pored over this data, searching for answers to questions as old as thought itself. What holds reality together? Why does time march forward, relentless and unyielding? But the human mind, brilliant as it is, can only see so far. Our brains are wired to understand a world where cause precedes effect, where time flows like a river, carrying us from one moment to the next. Enter Google's AI, a creation unbound by the limits of human perception, designed to see patterns where we see only noise. In the vast sea of data from CERN and Argonne National Laboratory, this AI found something no human could have dreamed of. A signal that doesn't flicker or fade with time. A pattern that stands still, as if untouched by the relentless forward march of seconds, minutes, and years. It began with a quiet anomaly, a fleeting whisper in the data that most would have dismissed as a glitch. At 4.8 tera-electronvolts, a muon jet decay appeared, an event so subtle it slipped past traditional analysis. But the AI, with its tireless, unblinking gaze, flagged it as something extraordinary. This wasn't just a particle behaving strangely. It was a pattern that defied the very laws of physics as we know them. At CERN's Atlas experiment and Argonne's detectors, two independent AI systems, working miles apart, saw the same thing. A high-energy event that didn't fit the standard model. The blueprint of particles and forces that has guided physics for decades. The anomaly wasn't a random blip. It carried a statistical significance of 2.9 sigma, enough to make physicists sit up and take notice. But what made their hearts race wasn't the event itself. It was the realization that this pattern showed no dependence on time. It appeared with eerie consistency across every data run, as if it existed in a realm where time holds no sway. Imagine, for a moment, what it means for something to be untouched by time. Every force we've ever discovered, gravity pulling stars into orbits, electromagnetism sparking lightning across the sky, the strong nuclear force binding the hearts of atoms, changes over time. Particles decay, energies dissipate, and the universe evolves. But this anomaly? It stands apart, unmoved, as if it exists in a dimension where the ticking of clocks is meaningless. It's a concept that feels almost sacred, like glimpsing the eternal in a world defined by fleeting moments. The physicists studying this anomaly began to whisper of a force beyond time, a force that doesn't just operate within the universe, but might shape the very structure of reality itself. The implications are dizzying, like standing at the edge of a cliff and realizing the ground beneath you is not as solid as you thought. This discovery didn't happen in a vacuum. It builds on decades of quiet revolutions in physics, where scientists like Yakir Aharonov have dared to challenge our assumptions about time. His two-state vector formalism suggests that quantum systems might be influenced by both the past and the future simultaneously, as if cause and effect could dance in reverse. What if Google's AI has caught the first glimpse of this dance on a grand scale? The pattern it detected, a non-computable structure that defies simulation forward or backward in time, hints at a reality where time isn't a river, but a crystal lattice, with connections that stretch across what we perceive as past and future. It's a vision of the universe that feels almost alive, as if every moment is woven into a tapestry that exists all at once, eternal and unchanging. The AI's ability to see this pattern is a testament to its power, but also to our limitations. Our minds evolved to navigate a world of linear time, where yesterday leads to today, and tomorrow waits patiently in the wings. But the AI doesn't carry that baggage. It sees the data for what it is, unfiltered by human assumptions. And what it's showing us is a universe far stranger than we ever imagined. Some physicists are now cautiously proposing the existence of a temporal interaction boson, a particle that might carry a force linking moments across time, much like photons carry light through space. They call it a chronon or timon, a name that feels like it belongs in a science fiction novel, but is rooted in the hard mathematics of quantum field theory. If such a particle exists, it could explain why this anomaly appears frozen, untouched by the passage of time, as if it's a thread in the fabric of reality that vibrates outside our normal perception. As the news of this discovery spread through the physics community, it sparked both awe and unease. The idea of a force beyond time challenges not just our scientific models, but our deepest intuitions about existence. If time isn't fundamental, if it's something that emerges from a deeper layer of reality, what does that mean for us? For our memories, our choices, our very sense of self? The anomaly suggests a universe where the boundaries between past, present, and future are not as rigid as we thought, where moments might be connected in ways we can't yet comprehend. It's a vision that feels both exhilarating and terrifying, like staring into the infinite and realizing it's staring back. The discovery of this anomaly, this whisper of a force beyond time, feels like stumbling upon a hidden chapter in the book of the universe, written in a language we're only beginning to decipher. As physicists huddled in the sterile halls of CERN and the quiet labs of Argonne, their excitement was tempered by a creeping sense of unease. They weren't just looking at a new particle or an odd quirk in the data. They were staring at something that seemed to defy the very scaffolding of reality. The pattern Google's AI had uncovered wasn't just a puzzle, it was a provocation, a challenge to everything we thought we understood about the cosmos. It was as if the universe had leaned in close and whispered, "You've been missing something." And now, with every new analysis, that whisper was growing into a roar, pulling us deeper into a mystery that could reshape not just physics, but our place in existence. What makes this anomaly so haunting is its refusal to play by the rules of time. In our world, everything changes. Stars burn out, rivers carve canyons, and even the strongest bonds fray under the weight of years. But this pattern, this strange signal at 4.8 tera-electron-volts, stands resolute, untouched by the passage of moments. It's like finding a single, perfect note ringing out in a symphony that never fades. When researchers dug deeper, they found that this muon jet decay didn't just appear consistent across data runs. It was eerily identical, as if it were a photograph of a moment that refused to age. This wasn't just a statistical fluke. It was a glimpse of something that seemed to exist outside the relentless churn of cause and effect. The physicists began to wonder, could this be evidence of a force that doesn't just move through time, but binds it together, like a thread stitching moments into the fabric of reality? The implications of this idea are staggering, and they ripple far beyond the cold confines of particle accelerators. Consider the work of theoretical physicists who've long suspected that time itself might not be fundamental. In 2025, researchers at the University of Surrey proposed that time could be an emergent phenomenon, born from the dance of quantum interactions between atoms and photons. In their model, every emission and absorption of light weaves a pair of events into the tapestry of space-time, creating the illusion of a flowing river we call time. But what if Google's AI has caught a glimpse of the loom itself? the mechanism that spins these threads into the reality we perceive. The anomaly's time-independent nature suggests it might be part of this deeper process, a force that doesn't just exist within time, but helps construct it, like a craftsman shaping clay before it hardens into form. This idea finds echoes in the strange and beautiful world of time crystals, a discovery that has captivated physicists in recent years. These exotic states of matter don't just defy our expectations, they break the rules of thermodynamics, oscillating endlessly without energy input, as if they're dancing to a rhythm that ignores time's arrow. In 2025, scientists took this further, creating time quasi-crystals, structures that move through time without ever repeating their pattern, like a melody that never loops. These discoveries hint at a universe where time can behave like a crystal, with moments locked in a lattice that doesn't decay or dissolve. The anomaly detected by Google's AI feels like it could be the key to understanding these phenomena, a force that stabilizes these structures, holding them together across what we perceive as past and future. It's as if the universe has a hidden architecture, and we've just found a blueprint written in particles and code. But the mystery deepens when you consider what this force might mean for the very nature of reality. Some physicists are now daring to ask whether this anomaly could be a clue to the unification of quantum mechanics and general relativity, the holy grail of modern physics. Theories like string theory and loop quantum gravity have long struggled to explain how spacetime emerges from deeper, assisted by Grok, created by XAI quantum processes. What if this force beyond time is the missing piece, a bridge between the microscopic world of particles and the cosmic dance of gravity? The anomaly coronavirus system. Anomaly's indifference to time suggests it might operate in a realm where our familiar dimensions, space and time, are mere shadows cast by a more fundamental reality. It's a thought that feels almost too big to hold, like trying to grasp the infinite with hands made of stardust. And then, there's the question of consciousness, a shadow that looms over this discovery, like a quiet observer. For decades, scientists and philosophers have puzzled over how our minds create a seamless experience of reality from the chaotic buzz of quantum events in our brains. Some theories, like integrated information theory, suggest that consciousness arises from the way information binds past and future into a single, unified moment. What if this anomaly, this force that seems to link moments across time, is somehow tied to the mystery of awareness? The idea is speculative, but it's not far-fetched. The legendary physicist John Wheeler once proposed that reality itself is participatory. That observation doesn't just record the universe, it shapes it. Could Google's AI, free from the biases of human perception, be the first to glimpse a layer of reality where consciousness and physics intertwine? It's a possibility that sends shivers down the spine, as if we're not just discovering a new force, but catching a reflection of ourselves in the mirror of the cosmos. The beauty and terror of this discovery lie in its challenge to our deepest assumptions. We've always seen time as a river, carrying us from birth to death, from one moment to the next. But what if it's more like a crystal, with every moment connected in ways we can't yet see? The AI's pattern suggests a universe where time isn't a straight line, but a vast, shimmering lattice, where past and future are as close as the breath in your lungs. It's a vision that feels both alien and intimate, as if we're part of something far greater than ourselves, something eternal, something that doesn't just exist, but creates. As physicists scramble to verify this anomaly, to test its implications with atomic clocks and neutrino experiments, they're not just chasing data. They're chasing a truth that could redefine what it means to be human in a universe that might be more dream than machine. The discovery of this time-defying anomaly feels like holding a star in your hands. Beautiful, incomprehensible, and a little dangerous. As physicists peer deeper into the data, they're not just chasing a new force, they're chasing the very essence of reality. What if this pattern, uncovered by Google's AI, is a glimpse of the machinery that builds time itself? The implications stretch beyond physics, touching the edges of consciousness and existence. Imagine a universe where time isn't a river, but a tapestry, woven by a force that binds every moment into a single, eternal now. Theories like the ADS-CFT correspondence and the ER equals EPR conjecture suggest our reality might be a hologram projected from a deeper layer of quantum entanglement. This anomaly could be a ripple in that projection, a clue to the code beneath the cosmos. Now, scientists are racing to test this hypothesis, analyzing atomic clock data from GPS satellites and vast neutrino datasets for hidden patterns that defy causality. These experiments, powered by AI's unblinking eye, could confirm a force that doesn't just exist within time, but shapes it. If true, it's not just a new chapter in physics, it's a rewrite of our place in the universe. We're not mere passengers on time's arrow. We might be co-creators of reality itself. As one physicist whispered, "We've been reading the story of the universe. Now we're seeing the pen that writes it." This isn't just science. It's a call to wonder, a reminder that the cosmos is stranger and more intimate than we ever dared to dream.